Welcome back to Logic Basics. Today we are going to actually start doing some logic problems with the two squares of opposition. If you recall, we are working towards doing these examples, and we're going to make our two squares for this today. Remember, this is from the Raymond McCall book. He says, granted the truth of the first proposition in each of the series below, designate the succeeding propositions as consequently true, false, or doubtful. Okay, so he's telling us pretend every neurotic is inhibited is true. Okay, we're going to pretend that's true for our homework. Now I'm going to go back to my iPad here where I have drawn two squares. I'd like you to do this in your notes. Two squares of opposition. The A corner for that first problem is every neurotic is inhibited. And I'm just going to abbreviate. It's easier if you abbreviate, take the words out and use the letters. Every N is I, every neurotic is inhibited. So this is our S term, this is our P term. From that, we could fill out the rest of this square. So if every neurotic is inhibited is our A statement, what's the contradiction? What's the O say? Got to learn this stuff, remember? So O says some N is not I. Okay, that's our O statement. What's the contrary? The contrary is over here. No N is I. Okay, no neurotic is inhibited. What's the contradiction of the E? It's I. And it says some neurotic is inhibited. Okay, now we have our two squares. Remember, last time I showed you how to get the second square's A statement. Do you remember how to do that? We're going to switch the S and P terms and negate each. So it's going to say every non-I is non-N. Okay, every non-neurotic is, every non-inhibited is non-neurotic. Now we're going to fill out the rest. So the contradiction is the O, and it's going to say some non-I is not non-N. Let me get this out of the way so that you can see. The contrary E statement, no non-I is non-N, and the I statement, some non-I is non-N. Okay, so now we have the original square filled out, the full contrapositive filled out for the these statements here. And then he tells us every neurotic is inhibited is true. Pretend it's true. So now we can fill out the truth values of all of these. So let's go over here, and he tells us A is true. Okay. Now we know the rules of the square, so now we have to start applying the rules. If A is true, the contradiction is false. And if A is true, the contrary is false. And if E is false, the contradiction is false. Okay? And if the A statement here is the same as the A statement on the second square, and this is true, the second square is also true. So the same thing. If A is true, then O is false. If A is true, then E is false. And if E is false, then I is true. So now we have 8 answers, possible answers to those questions. Which one is true, false, or doubtful? One other thing we need to put on here, though, is the reciprocal and the inverse. Reciprocal. Remember, the reciprocal says every I is N, and that is doubtful. That is, we don't know the answer to that. And then the inverse is over here. The inverse was every non-N is non-I. And that also is doubtful. Here, let me take that off of there. Let's put it here. Okay, So now we have 10 possible answers, 2 doubtfuls, and all of these answers. So what I would do if I were a student working on these problems is I would go to my worksheet over here and start finding the statements that fit on the square already. For example, every neurotic is inhibited is true. He tells us no neurotic is inhibited. We have to find that on the square. No neurotic is inhibited is an E statement, so here it is. No neurotic is inhibited. That's false. Okay? No neurotic is uninhibited. Uh-oh. No neurotic is uninhibited. That's an E statement, right? We have to figure out, are these A, E, I, or O statements first? So that's the first step. This is an E. No neurotic is inhibited. Uninhibited. So when I go to my square, I have to look at my E statements. Here's an E, no neurotic is inhibited. And here's an E, no neurotic is no non-inhibited is non-neurotic. And that statement wasn't either of these. It's kind of a halfway between these. It was saying no neurotic is non-inhibited. So if it doesn't fit on either one of these squares, that's when we have to either obvert it or convert it. So now I'm going to show you the flowchart. Let's go back to the flowchart and let's go through the steps. Actually, I should mute myself out of here again. So we have our 2 squares. Steps for finding true, false, and doubtful statements from the worksheet. The worksheet is this, okay? How do we answer these? The ones that are messy, like uninhibited or no uninhibited is neurotic, those are messy. So we have to go through these steps. Okay, first thing you ask is the statement from the homework, from the worksheet, an A, E, I, or O statement? Now it tells you how to do that. We've done this before. Identify the quantifier, all, some, none. Identify the subject, the copula, and the predicate. So all of these statements have that in the homework. Is the statement on one of the 2 squares exactly as it appears in the worksheet problem? Okay. If yes, if it's exact, then is the statement true, false, or doubtful? And you find your answer and you're done. Stop there. But if no, if it's not exactly, then check to see if it's an E or an I statement that can be converted so that you can get your answer. Is this the ideal world scenario? Remember I told you can just straight convert an E that's backwards or an I that's backwards? Sometimes you'll have no inhibited is neurotic, and you can just switch that. So no neurotic is inhibited, and you can get your answer. So if it's an E or an I that can be converted to get your answer, you may do conversion first. Otherwise, don't convert first. It's not going to help you. All right. So if no, check to see if it's okay. If yes, stop. You're done. If you can just convert it, you're done. Get your answer. But if no, then go to number 3. Obvert the statement. So usually you're going to have to obvert first. Now, when you obvert, does the obverted statement now fit on the square? Is it on there? Exactly. If yes, is it true, false, or doubtful? Stop. You're done. If no, then go to step 4. Step 4, convert the statement. So sometimes you have to obvert it and then convert it again. Obvert, then convert. Does the converted statement fit on the square? If yes, is it true, false, or doubtful? Stop. If no, then is the statement the reciprocal or the inverse or the contradiction of the reciprocal or the inverse? These will always be doubtful. So if you're getting hung up, you're like, I obverted this, I converted this, I can't do anything else. Look to see if it's the reciprocal or the inverse. Actually, check to see if it's the reciprocal or the inverse first thing. All right, so here are the instructions, and you are going to use these instructions for this worksheet. I will help you with a couple of these. Now this is going to be tricky because I have to use the iPad and I have this drawn on it, and I can't, I've got this little program, I can't get a second page up. So you're going to have this in your notes. If you haven't put this in your notes yet, maybe you need to pause and write this down so that when I erase it, you have it still. All right, so I'm going to erase this now, and we're going to go to the, I'm going to go back to that, here, let's do number 3. No neurotic is uninhibited. I'm going to write this down. No neurotic is I'm going to say non-inhibited because I put non on my squares. All right, no neurotic is non-inhibited. That is messy because look, it doesn't fit on my original. This is an E statement. It doesn't fit on my original E. My original E says no N is I, and it doesn't fit on my full contrapositive, which says no non-I is non-N. So it's neither of those, which means that's the clue for me to do something to it. So I have to obvert it or convert it. Now let's look at this. It is an E statement. Here's my E. Can I just convert this and make it fit on the square? Can I just switch the S and P terms? No, I can't, because that's not going to help it out at all. It's still messy. What I need to do is get rid of this or add a non here. So what I'm going to do is obvert this statement. All right, so what is the rule for obversion for E? E obverts to A, right? And so my no is going to change to all. N will stay, is will stay, and I negate the P term. But notice, this is already a negated, so it's going to be like this. I, and 2 negatives cancel each other out, so it is going to be I. All right, notice that move I made. 2 negatives cancel each other out, so you have an I now. Now let's pause and look at this. All N is I. Or every N is I. Every neurotic person is inhibited. That's my original A on the square. Look at your notes. So this one we know is true. Why? Because it's in that A spot here where we said every neurotic is inhibited, and we said that's true. So this is getting me that answer, okay? Every neurotic is inhibited is true. Now, let me do one more for you, and then I'm going to set you loose to do the rest of these. Let's do number 4. What does 4 look like? 4 says no uninhibited is neurotic. So no non-inhibited is neurotic. All right, let me get my iPad back up for you. Is this an A, E, I, or O statement? It's E, right? Does it fit on the square directly? No, it doesn't. So we are going to, can I switch these and make it fit on the square? No. So what I'm going to do is I'm going to obvert this again. So E obverts to A, okay? And when we do that, we have all, we have non-I staying non-I, we have is staying is, and we're going to negate the P term, so now we have non-N. Now look at this. All non-I is non-N. Does that fit on our square? It turns out this is on the full CTP, full contrapositive A corner, and that is a true statement. So if you recall, the second square and the A statement over here was all non-I is non-N, and we said that was true. So there it is. That's your answer. It's true. Now, what I want you to do is to go through the rest of that handout, or not the rest of the handout, just this A section. Struggle with it a bit. See if you can go through the flowchart steps. This should help you. I don't know how else to explain it except going through each of these steps. Next video, what we'll do is I'm going to introduce you to the section C here. Let me see if I can get it up here. Section C starts down at the bottom. Every X is Y. And it continues over here. So if you can see all of those, section C, We're going to go through every one of those, and you're going to figure out true, false, or doubtful true, false, or doubtful for all of those. And that will be all 32 iterations of S and P. And that'll get you all the possibilities. And then when we do that, I will show you my real life logic problem. All right, it's going to be exciting.